So today we're going to go over how to solve quadratics using the quadratic formula. So the quadratic formula is this expression that may look a little intimidating, but it's just us substituting values for a, b, and c. So let me go ahead and write down what the quadratic formula actually is. So it's going to be a fraction. On top of the fraction in our numerator, we're going to have a negative b plus and minus the square root of b squared minus 4a times c, and the denominator will be 2a. So like I said, it looks a little intimidating, but we're going to be replacing all those variables with numbers. So when you are going to use the quadratic formula, you have to make sure that one of the sides is 0 before you plug in your values for a, b, and c. In this case, it's already set equal to 0, so I go ahead and labeled our a, b, and c. It's in standard form, so they were in order. So I start with the denominator. So 2 times a is 3, so it's going to be 2 times 3. Our b is the opposite. So this is why we're going to put negative 4 there instead of positive 4, since there's a minus in front of the b. Inside the radical, we have b squared, which is 4 squared, times the negative 4, minus negative 4, and then your 8 times c, which is 3 and negative 39. So I'm going to go ahead and highlight the steps that we're going to do, and we're going to do multiple steps at the same time. That way we don't make this problem longer than it needs to be. So we're going to do 3 things in our first step, which I highlighted. So let's go ahead and start simplifying the things that I highlighted. So negative 4 stays outside for now. 4 squared is 16 minus 4, the negative 4 is always there. And I multiplied 3 times negative 39, which is negative 117, over 2 times 3, which is 6. So now our goal is to condense this expression here. As you can see, it's getting smaller. And we're going to go ahead and stick with the inside of the radical. So we're going to do negative 4 times 117. So that's 16, that negative 4, that minus makes the 4 a negative. So that's why we're going to multiply a negative and a negative here. And we know that negative and negative, it's a positive. So this is why the inside of the radical is going to turn into addition now. Still over 6. And just like with PEMDAS, we do parentheses first. We're going to stick to our radical. We're going to simplify our radical before we continue with the outside of the radical. So we will do the addition inside the radical now. So that would be negative 4 plus and minus the square root of 484. If I add 16 and 468, I get 484. Then we're going to proceed and take the square root of what's inside our radical, which is called the radicand. And the square root of 484 turns out to be nice because it's a perfect number. So square root of 484 is 22. So we're going to have negative 4 plus or minus 22 all over 6. And since we have that plus and minus in front of the 22, that means we're going to have 2 different answers. We're going to have one for positive 22 and another one for negative 22. So I like to just separate my 2 equations. So we'll have negative 4 over 22, that gives us 18. And 18 over 6 is 3. So that's going to be one of our solutions. And the other solution is when we have negative 22. So negative 4 minus 22 over 6, our numerator is negative 26, and the denominator is 6. If I simplify this, I get negative 13 over 2. So those are our 2 roots. These are our x-intercepts if we were to graph them. And that's why I like to simplify and not just leave it as what we had here in red. Because if you're graphing, then it's easier if you know what the actual x-intercepts are. So here's a little review how to do the quadratic formula.